So now we want to look at factorizing quadratic expressions. What are quadratic expressions? These are expressions that can be written in the form ax squared plus bx plus c. Alright? I will say that a is the coefficient of the x squared, and b is the coefficient of the x, and c is a constant. What do we mean by a is a coefficient of the x squared? Let's say, for example, we have a quadratic expression looking something like this: 2x squared plus 11x plus 9, or something like that. What would be our a value? So the a value is what we call the coefficient of the x squared, meaning a is a value that's multiplied to the x squared. And what value is in front of the x squared, they're multiplied to it. 2. So in this case, a is 2. b is the coefficient of the x. What do we mean by that? b is a value that's multiplied to the middle term here, x, so b is 11. And c is what we are left with, constant. Not a term in x, it's just by itself. Suppose you have a quadratic expression like this: x squared plus x minus 4. See if you can pause the video and identify the values of a, b, and c. So a, coefficient of the x squared, is a value that's multiplied to the x squared. What value is multiplied to the x squared here? No, it's not 0. Yes, it's 1. If it's 0, there wouldn't be any term, because 0 times any value will give you 0, right? So a is a value in front of the x squared. Just as in the same way 1x is same as 1x, in the same way x squared is 1x squared. So a is 1. And b is a value in front of the x. So no, it's not 0. X actually means 1x. So b is 1. X is 1x. So that number there is 1 in front of the x. And the constant there is minus 4. Let's try and identify another one. Suppose we have 5x squared minus x plus 10. And I ask you, what are the a, b, and c values? So a, the coefficient of the x squared, the number in front of the x squared, is 5. What is b? The number in front of the x, or the coefficient of the x, number multiplied to the x. What is this number here? Negative, just as how x is 1x, negative x is negative 1x. So b is minus 1. And then what is c? The constant c is 10. Alright, so now we are all able to identify the values of a, b, and c on any given quadratic expression. Let's look at how we factorize these type of expressions now. Now here's a quadratic expression that we want to be able to factorize. Now one thing you'll notice is that these expressions consist of 3 terms. So you have the x squared term, you have the x term, and then you have the constant. Now, when factorizing these expressions, we first need to split the middle term. And by splitting, we need to rewrite the middle term. Rewrite is a better term than splitting. We need to rewrite the middle term. So we need to rewrite 9x using 2 numbers. But remember, you have an infinite amount of numbers can add or subtract to give 9x. I could rewrite 9x as 7x plus 2x, 5x plus 4x, 6x plus 3x, 8x plus 1x, 10x minus 1x, 30x minus 21x, 100 minus 91x. I still get 9x. So there's an infinite 19 minus 10x, yes. So there's an infinite number of ways that we can rewrite a 9x. But whatever 2 numbers we use to multiply, to add to give 9x, or to rewrite a 9x, those 2 numbers must multiply or have the same product as A times C. That's the two last numbers. And we all know to identify A and C. A is the number times the x squared, C is a constant. So A is 2 and C is 10. So A times C is 2 times 10, AC is 20. So whatever pair of numbers we use to rewrite the 9x, that pair of numbers must multiply to give the same value as AC. In this example, 20. So the best way to go about it is to write down all the set of numbers that multiply to give 20. What are the pair of numbers that multiply to give 20? 1 times 20, obviously. What else multiply to give 20? 4 times 5 multiply to give 20. What other two numbers multiply to give 20? 2 times 10. The pair of numbers we use to add to give 9x has to come from one of these. It's just a matter of selecting which of these two numbers add or subtract to give 9x, and yes, that's this pair. So the first step is to rewrite the middle term. Using two numbers that obviously, of course, add to give 9x. Because remember, you're rewriting 9x, so you couldn't use any other pair except 4 and 5. That's the only pair that's add to give. And again, what's special about these pair numbers? They multiply to give 20. They have a product of 20. And that is the reason why we use 4 and 5. And then we have a plus 10. Now, observe something here. Notice something very important. All I did in my first step is to rewrite the middle term. Notice we still have our 2x squared. Notice we still have our positive 10. All I did is rewrite the 9x. And 9x, of course, is 4x plus 5x. And we use 4 and 5 because this pair of numbers, they multiply to give AC. Alright, and after we have the four terms. Watch the video and factor by grouping. We factor by group. Alright? And with factor by grouping, we separate these four terms into groups of 2 and factorize each group separately. For the first group, what's the common factor there? The 2 is common, definitely. And the x is also common, so we take out 2x as the highest common factor. And now we need to determine what goes in the bracket, and how can we do that? We can divide each of these terms by whatever your factor outside, the 2x. Alright, so 2 into 2 goes 1, x into x squared, we're left with x. And here, x into x, that's 1, 2 into 4, that's 2, positive 2. The other pair, or the other group, 5x plus 10. What number can go into 5 and 10? Correct, that's 5. Is the x common? No, because the x is not in the 10. So 5 is common, so we factor out 5. And if we factor out 5, what are we left? 5 into 5, 1, so that's 1x. And here, 5 into 10, 2. And as usual, remember we always get a common bracket. If you don't have a common bracket, mean you did something incorrectly. Alright, what's the common factor here? X plus 2. And then outside the brackets, we have 2x and positive 5. Good? And that's it. Let's try another one. Here is another one. So remember, the aim of the game here is to rewrite the middle term, 8x. But whatever two numbers are used, those two numbers must multiply to give AC. So the first thing you want to do is know what AC is. AC is A times C, is the coefficient of the x squared, which is 1. That's what A is. And C is the constant. So A times C is 1 times 12. Remember, x squared is 1x squared. So the A is 1, the C is 12, so AC is 12. 1 times 12. So we write down all the set of values that multiply to give 12. Obviously 12 times 1. Anything number of times 1, you get back the number, right? What else multiply to give 12? 4 and 3. What else? 6 and 2. Any other pair of numbers multiply to give 12? Can't think of any. So which of these pairs a number add to give 8x? 6 and 2. And so we rewrite this x, the 8x, using 6x and 2x. Why? These two numbers add to give the 8x, because obviously you're rewriting 8x, so obviously these two numbers must add to give 8x. But we want them to also multiply to give AC, which is 12. So we have 4 terms, so we group them into groups of 2. Alright, so for the first one, first pair, x squared plus 6x. What's our common factor? X, yes, x is common. So we divide both of these terms by x, and this is just to help us. And this is not necessary. It's just to assist us with the terms for the brackets. Alright, so x into x squared, we get x. And then x into x, that's 1, so we're just left with 6. The 2x plus 12, what's our common factor? I guess, right, 2. So we need the terms for the bracket. So we can divide each of these by whatever we have outside 2. So 2 into 2, that's 1, so 1x. And 2 into 12, that's 6. And notice, you always get a bracket that's common. If your bracket not common, it means you either factorize incorrectly or you use a wrong pair of numbers. So our final answer now, the common bracket is x plus 6. And you factor out x plus 6. What are you left with? X and 2. Positive 2. And we are done. Let's look at some more examples in our next videos.